This is problem number 7 from the sample test problems for test number 3. Find the exact value of the 9th root of negative I. Okay, so this is a little bit of a process here. Let's go ahead and give a name to that thing. We'll call it Z. 9th roots are not so great. How about we take the 9th power of both sides? Z to the 9th equals negative I. All right, what I'd like to do is maybe instead of writing it in this form, let's write it in our r cis theta form. So instead of Z, I'm just calling Z a cis, like a cis number, a polar number. I still don't know what R is. I still don't know what theta is, but in this little intermediate here, I'm just saying let R cis of theta represent the complex number Z. And if we're doing r cis theta form on the left, then it feels like on the right-hand side we should do the same. So let's go ahead and plot the right-hand side, which is negative I. So where does that live? That lives right down here at negative 1. This point is negative 1I. So in terms of r cis theta, okay, so how much is the r, which is the distance from the origin to the point? We can see here that r is 1. And how much is the theta, which is the angle going from the positive x-axis, or I guess the positive real axis, going counterclockwise until we land at the point, and that's 270 degrees. You're welcome to use radians here. I'll use degrees, doesn't matter. So what that means is that the right-hand side, this negative I, in r cis theta form, I was worried that was going to happen, r cis theta form is equal to 1 cis of 270. 1 cis 270. On the left-hand side, something very nice happens when we use de Moivre's theorem. We know we can bring that 9 in, it's r to the 9th, and the really nice thing that happens is that theta gets just multiplied by the 9. So it's r to the 9th cis of 9 theta is equal to 1 cis 270. And now we're going to go ahead and make two different equations. Seems to make sense to make the r to the 9th equal to the 1, and to make the 9 theta equal to the 270. In class at this moment, we would then maybe, if we wanted to find all the 9th roots of negative I, we'd stick on here a plus 360k. And then we'd have to pick all the different values of k. We're not doing that here, so I put it in a different color and we'll just kind of separate it because we only want the single one, the square root of negative I, the principal square root. So I think just the 270 by itself is fine. The first equation, take the 9th root of both sides, choose r equals positive 1. Second equation, divide by 9, theta is 30 degrees. So I think pretty much we're done. We were after z, that's the thing we defined in the very beginning, and then we decided to let z equal r cis of theta for r and theta to be determined. We just determined them. 1 cis 30 degrees, that's the answer. But it's kind of strange to put the answer in polar form when the original problem involved a number in rectangular form. So let's go back. 1 cis theta literally means 1 cosine of 30 plus I sine of 30. Guess I should not have said it quite like that. So I'll say it again. 1 cis 30 literally means 1 cosine 30 plus I sine 30. Cosine of 30 is root 3 over 2. You can check it out on your unit circle. Plus I times sine of 30 is 1/2. So we get root 3 over 2 plus 1/2 I. That right there is the square root, is the 9th root of negative I.